Hello, and welcome to STEM in the Sunshine. In this first lesson on number 3, we would like to discuss a few things. Firstly, we would like to define exactly what a number is. Secondly, we would like to state the purpose of numbers. And finally, we would like to discuss the different types of numbers. So let's begin. What are numbers? Well, numbers are a mathematical concept or idea that is represented by figures or symbols that we call numerals. And what are the purpose of numbers? Numbers are used to count, to measure, to label things, and to give things value. For example, someone can ask you the question, how tall are you? Or, how far is your house from the nearest police station? Or, how much do you weigh? Or they might ask you, how much money do you have in your pockets? These are all questions that can be answered effectively by the use of numbers. So, what are the different types of numbers? Well, the first type of number that we would like to discuss is what we call the set of natural or counting numbers, which is designated by the capital letter N. Now, this set of numbers has no fractions, no decimals, or any negatives. Some examples of the numbers contained in this set are the numbers 1, 2, 3, 4, 5, 6, 7, 8, straight on up to positive infinity. That is to say, there is an infinite amount of these natural or counting numbers. The next set of numbers we'd like to discuss is called the set of whole numbers, designated by the capital letter W. This set of numbers, like the set of natural or counting numbers, does not include any fractions, decimals, or negatives. Some examples of the elements of this set include the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, and again straight on up to positive infinity. And yes, there are an infinite amount of these whole numbers. The third set of numbers we would like to discuss is called the set of integers, which we will designate by the capital letter Z. Now, this set of numbers includes no fractions or decimals. However, we do include negative numbers in the set of integers. Some examples of the integers are the negative whole numbers, for lack of a better word, and the positive whole numbers. So there is an infinite amount of there is an infinite amount of integers. In the same way, there is an infinite amount of whole numbers and natural or counting numbers. The next set of numbers I would like to discuss is what we call the set of rational numbers. Now, the set of rational numbers we will designate by the capital letter Q. Reason being, the word rational comes from the word ratio, which is a quotient. In fact, the set of rational numbers includes any number that can be represented as a ratio or quotient of two integers, p and q. This set of numbers includes fractions, negatives, or decimals. Some How we can properly define the set of rational numbers by the letter, saying that the set of rational numbers can be represented by the letter Q, and the set of numbers included in this set are the numbers represented by the ratio P over Q, such that P and Q are elements of the set of integers, and Q is not equal to 0. Some examples of rational numbers include all of the integers. For example, the number 4, which can be represented by the ratio of the integers 4 over 1, or the number 27, which again can be represented by a quotient or ratio of two integers 27 over 1, or the number 0, which can be represented as 0 over 1. All integers can be represented by that integer over 1. Or we can look at a fraction such as the number 1 over 2 or the number 1 over 3, more commonly known as a half or 1/3. Now, when talking about rational numbers, there are a few things we want to keep in mind. Firstly, it is good practice to express rational numbers in their lowest form, quite simply because it's easier to work with a number once it's in its lowest form. For instance, if we have the number 4/8, we both know that the numbers 4 and 8 have a common factor of 4. If we divide 4 by itself, we get 1, and if we divide 8 by 4, we get 2. So 1/2 is the simpler or the lowest form of the number 4/8. These are two totally different numbers, but they represent the same thing, 1/2. Another thing we want to keep in mind when discussing rational numbers is that when we express a rational number as a decimal, we have two types of decimals, terminating and what we call non-terminating decimals. Terminating decimals have a finite number of non-repeating digits after the decimal point. For instance, if we look at the number 3/4, more commonly known as 3/4, 3 divided by 4 gives us the number 0.75. This number has just two digits after the decimal point. Or if we look at the number 21 divided by 8, this gives us the number 2.625, where the number 2 is the integer part of the number and 0.625 is the decimal part of the number. This number has 3 digits after the decimal point. Now, we also have what we call non-terminating, repeating, or periodic decimals. For example, the number 1/3 or 1/3, if we divide 1 by 3, we get 0.33333 recurring. That is to say, the number 3 repeats itself infinitely after the decimal place. How this is represented is by putting a dot over the number 3 or a bar over the number 3. This indicates that the number 3 is repeated infinitely after the decimal place. Or for example, if we look at the number 17 divided by 99, the answer for this number is 0.171717, and the 17 repeats itself on and on and on infinitely. So we can represent this number by saying that 17 divided by 99 is equal to 0.17 with a bar over the 17. And again, that bar over the 17 indicates that that group of digits, 17, repeats itself infinitely after the decimal place. We can also have negative rational numbers. For instance, if we have the integer -3/7, that gives us a -3/7. Or if we have the integer 7 over the integer -10, that gives us a -7/10. I should also mention that if you have two negative integers in the numerator, one in the numerator, the other in the denominator, the resulting rational expression is a positive rational number. Similarly, if you have a negative integer in the numerator and also a negative integer in the denominator, the resulting rational expression is positive. One more thing I should mention about rational numbers is that there is an infinite amount of rational numbers. In the same way, there is an infinite amount of integers, whole numbers, and natural or counting numbers. Another type of number we would like to look at is called the set of irrational numbers. Now, unlike the set of rational numbers, the elements of the set of irrational numbers cannot be expressed in the form p/q, where both p and q are integers. Now, there is no universally accepted designation for this set of numbers, but we will use the letter S to designate the set of numbers for the purpose of this presentation. Another thing I would like to mention about irrational numbers is that irrational numbers have an infinite amount of non-repeating digits behind the decimal point. Some examples of irrational numbers are the square root of 2, or the negative square root of 11, or the number pi, which, as we all know, is the ratio of a circle's circumference to its diameter. The number pi, as we may or may not know, has an infinite amount of non-repeating digits behind the decimal place. But for the purpose of this presentation, I have shortened it to just 3 decimal places. The last set of numbers I would like to discuss in this lesson is called the set of real numbers. Now, this set of numbers is designated by the capital letter R, and it is the union of the set of rational numbers and the set of irrational numbers. One way we can look at the set of real numbers is if we look at the set of natural numbers and we see that the elements of the set of natural numbers, better yet, the set of natural numbers is a subset of the set of whole numbers, which itself is a subset of the set of integers. And the elements of the set of integers, or the set of integers, is a subset of the set of rational numbers, which itself is a subset of the set of real numbers. And this relationship can be summarized in a Venn diagram. Here we have the set of natural numbers in purple, and we have 2 examples of natural numbers. And the set of natural numbers is a subset of the set of whole numbers, which itself is a subset of the set of integers, which itself is a subset of the set of rational numbers. And we have the irrational numbers out here. And the set of rational numbers are a subset of the set of real numbers. So we have the set of rational numbers here, and they are all contained within the universal set of real numbers. Or we can see where the combination or the union of the set of rational numbers and the set of irrational numbers gives us the set of real numbers. So in summary, let us briefly look at what we discussed in this lesson. Firstly, we said that numbers are represented by figures or symbols that we call numerals. We also said that numbers are mathematical concepts that we use to count, to measure, and to label or quantify things. We also discussed several types of numbers. Those are the set of natural or counting numbers, the set of whole numbers, the set of integers, the set of rational numbers, the set of irrational numbers, and the set of real numbers, which we said encompasses all of the other sets of numbers. So there you have it, an introduction to number theory. I hope this lesson has been informative to those of you watching this video. Don't forget to subscribe to our channel, and please like this video watching.